All right, 3.3. Basically, we're going to be solving 2, 3, 4-step equations, okay? Now, in the different steps, there's only going to really be 2 as far as solving goes, okay? But there will be other steps that we have to take to simplify it before we solve, okay? So that's why I'm saying there's 2 or 3 or 4 steps. Most of these will only have, you do multiplication and then you'll do addition and everything will be, that'll be done. But your basic equation, which is what we talk about when we're solving linear equations, your basic equation looks like this. 2x plus 7 equal 15. Okay? So when I have more than one step to solve, you will solve the addition and subtraction. Let's make that or subtraction first. Okay, so in this problem, 2x plus 7 equal 15. What I'm going to do first is I'm going to solve the addition part by subtracting 7 to both sides. Remember, when we're solving an equation, we're trying to get the variable, in this case x, by itself on one side or the other of the equation. Okay? So to do that, we have to do the inverse operations that we've talked about in 3.1 and in 3.2. Okay? The inverse of addition is subtraction. That's why I'm subtracting. Over here, it makes that 0. So I have 2x plus 0 equal, what's 15 minus 7? 8. Okay? So that leaves me with 2x equal 8. Okay? Now, the second step, or the final step, is to solve the multiplication and division last. Okay? So, the inverse of multiplying by 2 would be what, Zach? Dividing by 2. So I got to divide by 2 to both sides. That cancels out, leaving me with x. X is equal to 4. Okay? So obviously, those are fairly simplistic. Okay? Let's deal with one that has a fraction in it. Let's see here. 22 equals 18 minus 1/4 x. Okay? Now, obviously, the two steps are the multiplication there and the subtraction there. I'm going to rewrite this problem as 22 equal 18 plus negative 1/4 x. The reason I'm going to do that is to make sure that I do the right inverse operation. Okay? The correct inverse operation here would be to do what first? Subtract what? Subtract 18 from both sides. That cancels. Okay? 22 minus 18 would be what? 4. So 4 is equal to negative 1/4 x. Okay? So I have a fraction in front of the variable. So what do I do when I have a fraction in front of the variable to solve it? What? Do the reciprocal. We multiply both sides by the reciprocal of negative 1/4, which is negative 4 over 1. Okay? So we're solving by multiplying by the reciprocal. So I got to do the same thing over on the other side. Negative 4 over 1 times. Okay? So these two over here cancel out, leaving me with x. Negative 4 times 4 would be what? Negative 16. So x is equal to negative 16. Any questions on those two before I move it on it? All right, next, let's talk about combining like terms before we solve. Let's look at this one. So this is combining like terms. Okay, combining like terms before you solve. All right, now, let's see here. X plus 5x minus 5 equal 1. Okay, now, on the exam, some of you are still having struggles with this. You got to get it down. It's not going to go away, as you can tell. Okay, what are the like terms in this problem? Caleb? X and 5x. Okay, I have 1x and I have 5x's. So I'm going to put those two things together because they are the same. So if I have 5x and then I put another x with it, how many x's do I have? 6 x's. So I have 6x minus 5 equal 1. Okay? So in other words, what I had here, I had 1x plus 5x. And that's equal to the 6x. Okay, now I've combined like terms. I just solved now, because it's already back in a normal form. So I solved by taking and adding 5 to both sides. Cancels over here, leaving me with 6x equal what? 6x is equal to 6, because 1 plus 5 is 6. So I added to both sides to solve. Now I'm solving again. Now I'm going to divide to both sides. Divide by 6, divide by 6. They cancel out, giving me 1x. They cancel out, giving me 1. And 1x is 1. Okay. Brittany. I know. I just do that to her occasionally, so I thought I'd do it to you occasionally. Why did I change subtraction of 5? Yeah. I can do that. Let me show you here. If I have 6x minus 5 equal 1, I can change that to plus and negative. Okay. The problem you run into there is to do the inverse of it. That means I've got to subtract a negative 5 to both sides. Okay. That cancels out. Now I have 1 minus negative 5. Well, 1 minus negative 5 means I have to do that right there. And so 1 plus 5 is 6. So instead of doing all of that, it's easier just to do the inverse of it right there, because that's eventually what you're going to do. Okay? Now, let's look at the next type. Distributive property. Okay, using an equation that has distributive property. Here we go, 12 times 2 minus x equals 6. Some of you still struggled with this on the test, on the exam. Okay, well, we distribute 12 to both things inside the parentheses. It does not go across the equal sign. It only does the things that are inside the parentheses. Okay? So what that means is I have 12 times 2 minus 12 times x equal 6. 12 times 2 is 24 minus, not equal, minus 12x equal 6. Okay, so now that gives me 24 plus negative 12x equals 6. Now, the reason I'm changing it there is because that negative sign belongs to a multiplication part of the problem. It doesn't belong to a factor of just adding or subtracting. Okay, that's the reason I'm changing it there, and I didn't change it at the other place. Okay, when this variable is behind the subtraction sign, then you need to change it. Okay, so in other words, if it would have been 12x minus 24, okay, then yeah, just go ahead and just do plus 24, and you're okay. The reason we're not doing it here is because I'm not subtracting 24 from 12x. Okay? This is subtracting 24 from 12x. Okay, in this problem, I'm subtracting 12x from 24. Okay, that's why I have to change it here, and I didn't change it at the other place. All right, so that means to solve this, I've got to subtract 24 from both sides. So subtract 24, that cancels, subtract 24. So that gives me negative 12x equal, what is 6 minus 24? What? Negative 18. Do what? That's a minus sign. Those are minus signs, not negative signs. So, now I have to solve by dividing by negative 12, not negative 72. So I divide by negative 12 to both sides. Gives me x is equal to what? What? I heard somebody say it. 1 1/2. X is equal to a positive 1 1/2. The reason it is positive because I have the two negatives I'm dividing by. All right, now Let's talk about multiplying by the reciprocal. Okay, and you're thinking, well, we already multiplied by the reciprocal. Not like I'm talking about. All right. You have this right here. Negative 4 over 9 times 2x minus 4 equal 48. Now, by what we just talked about, you would say, what would I need to do here first? By what we just, the example I just gave you, what would you think that you would do first here? Caleb, the distributive property. Because we just did 12 times 2 minus x. Okay? But the problem you got here is you're dealing with a fraction. And multiplying, the fraction times several things inside of parentheses we don't want to do. Okay? So here's how you can get rid of it. Let me show you a different problem. If I had this right here, what would you do to solve that? If I had negative 49 times x equal 48, what would I do to solve it, Brianna? Right. We'd multiply both sides by the reciprocal. Okay? Well, all they are saying is 2x minus 4 is the x. Okay? So I can do the same process here. Okay, I can take negative 4 over 9, 2x minus 4. I'm just rewriting it so I don't have that right underneath it. And I just multiply both sides by the reciprocal. Okay, and so what that does over here is it cancels out that fraction. So all I have over there now is 2x minus 4. Equal, now I cross cancel. 4 into 4 once, 4 into 48 12 times. So what is 12 times negative 9? 108. Negative 108. Okay, so that's my new equation. So I simplified. So right here, I simplified by multiplying the reciprocal to both sides. Now, please understand, okay? Let me solve this and then I'll go into that part. 2x minus 4 equal negative 108. Okay, so what I got to do to solve it? So we're going to solve here by adding 4 to both sides. Right, Matt Shelton? Okay, just making sure you're still with us over there. That cancels, leaving me with 2x is equal to, what is negative 108 plus 4? Brandon? Negative 104. Okay, now to solve, I'm going to divide by 2 to each side. So divide by 2, divide by 2. That gives me x is equal to what? Negative 52. Okay. Now, understand that what I did here, okay, that is not the same thing as this. Okay? This is not the same as Those two are not the same. Okay? So please understand that I didn't say that you can take and multiply by the reciprocal because of this right here. The only reason I can multiply both sides by the reciprocal is because that fraction was outside the parentheses. So instead of distributing it to everything inside the parentheses, I multiplied both sides of the equation by the reciprocal. Okay? Now, the next one. And obviously we get a little harder this time. (4x over 3 plus 3 equal 23). Now, there are two different ways that you can solve this. Okay? They are both similar. And the book doesn't give me an example of how they want you to do it, so I'm going to show you both ways. Okay? Let me make sure here. All right. The first way is this. I can take that right there, and I can take I'm rewriting it because I want to show you what I'm going to do here. I can take and multiply everything in here by 3. Okay? The reason I do that is because I can cross-cancel those two 3's, leaving me with 4x plus, what is 3 times 3? 9. What is 23 times 3? 69. So there's your new equation. Okay? That's one way that you can do it. The other way that you can do it, and I don't really care which way you do it, is you can understand that this right here is the same equation. Okay? So either way, you will come up with exactly the same answer. Okay? And I'll show you both ways. If I'm over here with the 4x plus 9 equals 69, then I simply, to start solving it, subtract by 9 to both sides. 69 minus 9 is 60, which is equal to 4x. Here I divide by 4, divide by 4, x is equal to 15. So over here, with the fraction equation, you do the same thing. I subtract by 3, which cancels. 23 minus 3 is 20. 4/3 x is equal to 20. Okay? Then to solve that, I multiply by the reciprocal to both sides. Those cancel, leaving me with x is equal to 20 over 1 times 3 over 4. Cross cancel. 4 into 4 once. 4 into 25 times. 3 times 5, 15. Okay? So it really doesn't matter which one you do. Okay, it's just a matter of which one you understand the best. Maybe you go, I don't understand either one. Okay, let's look at another one of those because I know that's a little bit more precarious than the others. Okay, let's say you have that. Negative 10 equal 4 minus 7x over 4. Now, once again, what I'm going to do before we even start is I'm going to do this. Once again, the reason I'm changing that subtraction to addition is because the variable is behind the subtraction sign. Okay? Now, to get rid of that 4, I can simply multiply everything by 4. Okay? And so that gives me negative 40 equals 16 plus negative 7x. The reason that's negative 7x is because those two 4's cancel each other out. Now, you solve it from that point. What'd you get, Caleb? No. No. Matt, 8 is correct. 8. Here's why. Okay? First things first, subtract 16 from both sides. That cancels. Now, remember, this here is negative 40 minus 16, which means plus a negative. So that gives me negative 56 is equal to negative 7x. Now I just divide by negative 7 to both sides. All right. So, anyone not understand how I came up with that? So, one of the typical problems that we've had in the past looks like this. Negative 10 is equal to 1/2 x plus x. Well, that's not the one I wanted. Let me redo this one. Like that. Okay? Well, you can do that particular problem just like I've showed you to do these. I can take and multiply that problem, everything in that problem, by 2. Okay, and what happens to that is that gives me negative 20 is equal to, those two cancel out, so that just leaves me with 1x plus 8. Okay, and I've just got rid of the fraction. You can do that on every single problem that has a fraction in it. So let's go back up here to the top. Let's see here. Where was it at? Right here. No. Yeah, right here, where we did the 1/4 x, the negative 1/4 x we started with right here. So if I wanted to redo that problem, let me take it down here and I'll show you. We had 22 equals, what, 18 minus 1/4 x? Yeah, 18 minus 1/4 x. Okay? So instead of taking, subtracting, all you got to do to get rid of that is you just take and say, okay, 4 times 22 is equal to 4 times 18 minus 4 times 1/4 x. So that's 88 equal 72 minus those 4 cancel out x. Okay, and you can do it the same way. That's plus and negative. So I subtract 72, that gives me 16 is equal to negative x. Well, if negative x is equal to 16, what's positive x equal to? Negative 16. Okay? So essentially you get the same, we got the same answer. It's just a matter of whether what you understand the best. Okay, eventually you're going to have to know how to do it this way. Okay, because in the future you're going to have a problem like this, and it may be in the next section. I don't remember where it starts getting in this book. But you may have this. You may have that. Okay? And we look at these denominators. So what you would do there is you would multiply by the least common multiple of 2, 4, and 6. What is the least common multiple of 2, 4, and 6? 12. So you would take and multiply everything by 12. You would take 1/2 x, multiply it by 12, take that, multiply it by 12, take that, multiply it by 12. And I can get rid of all the fractions that way. Okay? Well, those two cancel out, making that 6 and 1. So that's 6x plus those two cancel out, making that 1 and 3. 3 times 3 is 9. Those two cancel out, making it that. And so you have that. Okay, that's eventually where we're going to. Okay? So that's why they're talking about multiplying by the reciprocal. They're talking about multiplying by whole numbers, things of that nature. Okay? Now, your homework. Your homework is 3.4 or 3.3. Is it 3.3? 3.3. 3.3, 16 through 40 even, and 50 through 58 all. Think they're hard word problems? Why would you ever think that? I know, that's why I give them to you, because y'all don't like them.